Good morning to everyone. I am Priyadashni, Assistant Professor of RIT Mechanical Department. Now I am going to teach about the CNC part programming. CNC milling part programming. This is the diagram for a milling operation. Now the part programming is written with the help of G and M codes. This G code is known as a geometrical coding and the M is called a miscellaneous coding. Okay, then this G code is always refer the geometrical operations of a tool, and the miscellaneous code is an example for coolant on off, spindle on off. These instructions are given with the help of M codes. Now I am going to say some important codes for part programming. First one is the G90. G90 is called absolute programming and G91 is called incremental programming. What do you mean by absolute and incremental? Absolute means every time the tool is going to start with the reference point only. If I am going to draw a square and this is my reference point. If I write G90 means every time the tool is going to start from here only. If I am going to write the program with G91 means that tool is starting here in the first line, and the second line the tool is going to stop here. Now the third line is going to start from here only, not to return to its reference point. That is called a G91 incremental programming. So every time the measurement take from here to here, then here to here, then here to here, then here to here. That is called a incremental programming. This too is a make two codes, G90 and G91. Then important codes are G01. G01 is known as a linear interpolation. My tool is going to travel along a straight line means that is a G01 code. Then G02 means it is a circular interpolation in a clockwise direction. My tool is going to rotate in a clockwise direction means that is indicated by G02 code. The same is Z03. This is also known as a circular interpolation, but in the counterclockwise. My tool is going to start from here to here and travel along a counterclockwise direction means that is denoted as a G03 code. Then a very important code is a G41, G42. These two codes are mainly important in a milling program. This is sometimes not necessary for the lathe program, but in the milling program we definitely need these two codes. G41 is a left compensation. My tool is going to start from left to right or right to left. These are two main positions. My tool is going to left compensate means that time I am using a G41 code. My tool is going to compensate in a right direction means that at that time I am going to use a G42. So G41 is for a left compensation and G42 is for a right compensation. This is also very important. Then here there is a X, Y, Z. These three alphabets we are frequently using in the program. So X means the coordinate of X direction, and this is a coordinate of Y direction, and this is the coordinate of Z direction. Okay, so here I am writing a Y and X. So in this problem or in this diagram we don't have any holes or pocketings. If I am having any pocketings or holes means at the time I am using a third coordinate also. But in the diagram I am using only two directions, so I take only X and Y. So this is the three alphabets shows the three coordinates X, Y and Z. Then we need to specify the feed of 0.5 or something. That is a feed per minute rate. So we need to write the feed and we need to write the spindle speed. So S1000 means that is indicating the speed of the spindle. Okay, now first we observe the milling diagram. So I am just put a plus mark here, that is called a reference point. That means my tool is started from here only. So I am going to travel from this direction or otherwise this direction. That is my own decision. I can start from here to here and start with this point, or otherwise I can start from here then start from here. So end with here. So that is my decision. So according to that I can select a G41 or G42. So first I am going to start from here and I am going to travel from this direction. Okay. So first G90. So G90 means a absolute programming. So for this program I choose a absolute programming. And then G01 linear interpolation. So my tool is going to start in a linear direction at first. Then x0, y0. So obviously my reference point is here. So I am take a 0, 0 position. Then feed and speed rate. Second line x30. So in the linear interpolation, so the linear direction, my tool is going to move from x0 to x30. So but remind the y is 0. So I need not to write in a y0, otherwise if you want you can write y0. So first start from 0 and end with the x30. And then second step Z03. We know that Z03 is a counterclockwise direction. So counterclockwise direction in x54. So first start from here x0 and this is 30 and this is the radius of 12. So the diameter of the curve is at 24. So totally 54. So my tool is now placed here. So I am going to draw arc from here to here. So obviously this is the counterclockwise direction. So I am write a G03 code. If I am starting my tool from here to here means, if I am here writing this place instead of x54, if I am writing x30 means I am going to draw arc from here to here. So at that time I can write G02. But now I am just indicating x54. So obviously my tool is now placing in this place. So we need to draw arc from here to here. So I am writing G03 for the counterclockwise direction. Now I draw an arc. Then next from C to D, that is a linear. So I write a G01. So totally the direction is in this direction. The x count is 30 plus 24 plus 28. So 82. So I write a x82. Then the next step D to E. That is a curve. So I am writing a G02. Why? Because I am starting a curve from here to here. Starting from here and end up with here. So I write a G02. G02 is a clockwise direction. So clockwise direction I draw a curve. Then x08 the starting point and the radius of the curve. And the next one E2F. E2F is a linear direction. So Z01 and the x is ended up with the dimension of 123. So I ended up with the 123. So up to this line, okay. Then now I move to F2G. So in F2G, the G is at the distance of x80 and y is y45 direction. So now only I am going to move from y0 to 45. So I place the tool from here. So that place the dimension is a x80 and y45. Then next step, my tool is going to move from here to here. Now we need to listen one thing. What is that? So on, my tool is having a one side of compensation. But now my tool is started to compensate on the opposite side. So I need to write the compensation side. So first time, this is the left hand side and this is the right hand side. So my tool has a right compensation. So this up to this is a G42. But from this line, the tool is moving from right to left. So left compensation. So from here, I am right at G41. It's a left compensation notation. So I am writing G41. Then next step. From here to here is a X40 and Y75. G41. The next step is a X40. From here to here, X40 and Y75. At that place, I am having a one radius. So X35, Y80 and R5. I am just writing that is the counterclockwise. So I am using a G03 code. And the next step is going to J2K. So the same. Once I am writing G41, again I want to change now. At the time only the compensation will change. Otherwise, the consequences lines are following the same compensation. So the J2K is following the same G41 compensation at the distance of 20. Then again I have one curve. That curve is a G03 and X0, Y80 and R10. So because the radius is at 10 and the radius is ended up with the 0 position. So that's why I am writing X0, Y80 and R10. Then we need to come down the tool to our reference point. So last point is a Z01, Y0. The last reference point, I reach my tool. That tool is reached to my reference position. So this is a very simple milling diagram with the program. Thank you.